First, sample of the vernier caliper, not the original vernier caliper. The difference will be, what will be the difference? One, original will be more accurate and it will be made of steel. This is just for a reference. But you can see here, before I start, I'll just explain a little. You have a main scale reading. This is the main scale. We have a main scale reading here. Okay. Then we have a vernier scale reading on this. Okay. Okay. So whatever I am going to teach, I will be showing that today. Sure. So whatever I take here today, we'll show about starting the machine and everything, the parts and everything. That thing we'll be showing there in the machine also today. Okay, that's what I'm planning now. So I told you this is the main scale. This is the vernier scale. Okay. Here you have some dimensions in the vernier scale reading, and in the main scale you have some dimensions, right? How we will read this? So on the top side it will be, bottom will be in millimeter and top will be in inches. Okay, so we will be using only the part. This side is used to measure the outside diameters. Here we can measure the outside diameters like this, and this will be for the inside diameters. Any hole or anything if you want to measure, we will be measuring it with this side. And what's the purpose of this? This is for checking the depth. Okay, this is the main thing. Now, first, whenever you get a vernier with you, you have to see the error, whether it is perfect. How we will see? You can see the 0 on the bottom and 0 on the top, right? 0 on the vernier scale, 0 on the vernier scale should be exactly matching with 0 on the main scale. Now here it is mentioned that the least count. What is the least count? Morse measurement, right? So the least count is 0.05. We have given it as 0.05. But in our normal machines, normal verniers, if it is an analog vernier, it will be 0.02. And digital vernier will be 0.01. Okay? Okay. Then this vernier and micrometer we have separate class detail. I just told about this. Keep safe with you. This is yours. Okay. Now let's go to the class. Today we will be learning some calculations and everything, because we need to know. I told you the spindle should be this much speed, the cutting has to be this much. All those things I have told you, right? So how we will come to that calculation? That's what we are going to see now. The first thing we will do is the cutting parameters. What is a cutting parameter? Cutting parameter ಅಂದ್ರೆ cut ಮಾಡೋದಕ್ಕೆ ಏನೇನು ಬೇಕು. What are the parameters for cutting? That's what we are going to discuss. Why is that important? Because cutting parameters decides the quality of the work, the tool life, proper chip breaking and tool cost. Why? If you give more cutting speed, feed or anything, what will happen? The final finish which we get, it won't be proper. Or if you are giving overspeed or overcut, what will happen? The tool may break easily. Understood? So, first thing we are going to study is the cutting speed. Cutting speed. What is cutting speed? What is speed? What do you mean by speed? Speed, basically. Going from one place to another, right? The movement, what is the force it go? So, cutting speed means at what speed it will be cutting. At what speed it will be cutting. Okay. So, first thing, but before cutting speed, I will be taking spindle speed. What is spindle speed? Spindle speed is RPM, the rate at which the spindle rotates. So, it is measured. How is spindle speed measured? It's always in revolutions per minute. Revolutions per minute. I told you yesterday, rotation per minute or revolution per minute. So, to calculate this spindle speed, we have the formula N equal to 1000 into V divided by pi into D. 1000 into V divided by pi into D. Or normally we say V equal to pi dn by 1000. To remember easily. V equal to pi dn by 1000. But V equal to pi dn by 1000 is another formula. Both of these are same. What is happening? From here I took it here. All the changes happen. Fraction, multiplication of fraction. In school we studied, na? Similarly I just substituted. Now here what it is there? N. What will be N? N is the spindle speed. Pi, what will be the value of pi? 22 by 7, or we will take it as 3.14. D, what will be D? D will be the diameter of the tool. The tool which we are using, the cutter which we are using. That is D. And what will be V? V is the cutting speed. Okay. Now we are using a dia 12 cutter, for example. Dia 12 cutter. Okay. Now how we will calculate this? For dia 12 cutter, what is the speed we require? For that, we have N is the one we have to calculate, right? This we don't know. Pi we know. Dia of tool we know, equal to 12. Cutting speed we don't know. So this cutting speed cutting speed is the speed at which the material is removed from the workpiece. Material is removed from the workpiece. Okay. Now, in cutting speed, normally we have a standard value for this. We don't want to find that separately. If we want, we can find this, but we don't have a spindle speed here, because for spindle speed we need cutting speed. So how we will get this cutting speed? By this formula we can get, if you know the spindle speed, or else can see here we have two types of this cutting tools. We have HSS, high speed steel cutting tools. We have carbide cutting tools also we have. So when we are cutting on different material, we have different types of materials. The material what? MS means mild steel, cast iron, aluminium, stainless steel, brass, copper. There are different materials in there. And all these will have standard cutting speeds. Now, for mild steel, in HSS it will be 20 to 30 and carbide it will be 100 to 200. So, when we want to check the spindle speed, one more thing we have to see? We need the cutting speed. For cutting speed, we want what is the tool and what is the material being cut. These two things has to be known. But tool ಅಲ್ಲಿ ಏನು ಬರುತ್ತೆ? HSS ಇಲ್ಲ ಕಾರ್ಬೈಡ್. Material ಅಲ್ಲಿ aluminum, MS or cast iron, brass, all those things will come in tool. Now we are going to take an example. We are cutting using dia 12 cutter, right? We are using a HSS cutter. So dia 12 end mill HSS cutter on MS material. MS ಅಂದ್ರೆ mild steel. Okay? Dia 12 end mill, HSS cutter and MS material. How much will be the value? We can take it from 20 to 30 meter per minute. Unit is must. Whatever you tell, unit is must. So 20 to 30. We will take a middle of that. What is that? We will be taken as, let us take as 25 meter per minute. We will take standard as 25 meter per minute because that is in between 20 and 30. It can be anywhere in between. We are taking as 25 meter per minute. Now coming back to the spindle speed. We are taking the values. So N equal to 1000 into V is to, we are taken as 25 divided by pi into D. So that will be 25,000 divided by 3.14 into 12. What will be? It will be 663.4. So we can take it as 650 or even 700, whichever you feel safe. For 12 mm mill, if it is MS material, we will be using the RPM as 650 or. Did you understand? Did you understand? Any doubt in this? Any doubt in this? How to calculate the RPM? Did you understand? If this formula is difficult to remember, just remember V equal to pi dn by 1000. That will be easier to learn, right? V equal to pi dn by 1000. That means V into 1000 equal to pi dn. So bring it down, V into 1000 divided by pi into D equal to N. Same thing, right? 1000 into V divided by pi into D, it is just this, V into 1000 by pi into D. Same thing. So if this is difficult to remember this. V equal to pi dn by 1000. Basically, yeah, pi is always same. No? Our in the mathematics pi. This is not other pi. This is the normal mathematics pi which we studied in the school. That is always 22 by 7. That is 3.14. To be exactly with 3.141 something like that. But we'll take 3.14. Any doubts in this? Any doubts? Okay. Then we have the feed. We have the feed here. How to calculate the feed? Feed, what is feed? What is the feed? Yesterday we told in all the lines we'll be writing. We'll write F150. Where we'll write it? G00 or G01? G01. In G00 will we put? Why? Rapid. It will automatically, if you put G00, it will automatically take the maximum speed available. So always keep that in mind. So G0 was, we are putting F150. What is this F150? It is the feed. At what speed it should go while cutting. Okay. How this will be calculated in mm per minute or mm per revolution. Why that difference? Mm per minute or mm per revolution. Why is that difference? I told it is measured either in mm per minute or mm per revolution. Why? Because we are not only considering milling machine here. We are also considering lathe also. So when it comes to lathe or round pieces, turning pieces, we'll go for mm per revolution. And for the other pieces, we'll go for mm per minute. Okay. So if a question comes, what is the unit of feed in turning? Turning a unit of feed, what will be the answer? Mm per revolution. Okay. So let's go to the formula. So the formula is F equal to, F is, what is F? Feed. Feed. F equal to SZ into Z into N. What is N? N we already learned earlier. What is N? Spindle speed. SZ is the feed per tooth. Feed per tooth. So this end mill cutters which we use now, it will have, what are the flutes? There's a cutting point and a path of the chip movement. So we'll see how many cutting points are there. How many cutting points are there in the bottom? So some tools will have only 2, some will have 3, some will have 4, and some will have more than that. Why? For some materials we need less flute. For some materials we need more flute. In that case, based on the, so then Z is the number of flutes. So here we are taking, which was the tool we are taking? Dia 12 mm, end mill with 2 flutes for example. We are taking 2 flutes. Okay. Now, and N is the RPM, speed, right? So now we are finding the feed. This feed per tooth, how we will get? Feed per tooth. basically when you get a tool, the cutter ಹೊಸ cutter time ಅಲ್ಲಿ they will give a data sheet. They will give a data sheet. Everything will have a data sheet. In that data sheet, it will be mentioned for every tool what is the feed per tool that can be calculated. So for 12 mm, for example, we are taking it as 0.05. What 0.05? What 0.05? mm per minute. Everything will be mm per minute. Our feed is, this is basically feed. Now we found the feed. Now we are finding the per tooth. That's all. That is standard value which is given by the manufacturer. The manufacturer will give the value. The number of flutes. What is the number of flutes here? What have we mentioned? 2. And RPM. What is the RPM we found earlier? We will take 650. Okay. Now we are finding the feed. What will be the feed? Feed equal to 0.05 into 2 into 650 mm per minute. That is it will be 65 mm per minute. Understood? Understood this value also? Because why we are calculating this? In the programming when we do, this will not be automatically calculated. We have to input the value. We will input the value. Based on the material, based on all things, we will input these values in the, there will be options. What will be the feed? What will be the cutting depth? All these things we have to input on the, we have to tell machine how much should cut. For example, this is my piece. The size is 10 mm. Height 10 mm ಇದೆ. I want to make it, for example, 6 mm. I want to make it 6 mm. ಎಷ್ಟು ರಿಮೂವ್ ಮಾಡಬೇಕು ಮೆಟೀರಿಯಲ್? 4 mm ರಿಮೂವ್ ಮಾಡಬೇಕು. Can we remove it at a stretch? Or a 4 mm? Now we won't give. We won't remove 4 mm. What we will do? Based on the cutter. If it is 12 mm cutter and all, we can give it to 1 mm also, not a problem. Based on the metal. If the soft metal, we can give 2 mm also. We are giving 0.5. We are removing 0.5. Then we will remove 0.5. We will remove 0.5. We will remove. So we have to tell the machine at a time how much material has to be taken. Basically, what we are telling, I told you our base, most cases, this is our table, this is our table, and we have the piece here. Okay? The table, the top, if the cutter, now dimensional and the edge of the cutter. So, the edge of the cutter, if it touches here, what does it mean? What is this point? That is the 0 point. 0 point. Understood? This is the 0 point. Then, what will be this point? 10. Whatever is the dimension of our piece. So, first we will tell in the CNC, when we do rapid positioning, G00, we will, it will be in the machine 0, tool machine 0. From there, I will tell to come to the center. Will I tell directly to come to 10? No. In the G00, we will tell, first we will move like this, and we will come like till 70 or 80 or 50. Means, for safety, now, ಸ್ವಲ್ಪ gap ಬಿಟ್ಟು till here. Maybe this is some 50 or 70 or 100. Let's check 100. Okay? till 100 mm, it has to come in full speed. From 100 mm, when we use G01, what will happen? It will start coming slowly down. It will start coming slowly down. Then first it will go till, then we have to instruct the machine how much it should go down. So I am giving 1 mm. I am giving 1 mm. So the cutter will come out of the tool, job, come down to 9 mm. Come down to 9 mm. Then it will take a cut. Again it will go down. It will take another cut. Again it will go down. And finally when it reaches 6, it will have the perfect damage. Understood the zero value? How we are telling the zero? Any doubt? Any doubt? So this feed, this is how we calculate the feed. This is a formula for feed. Then next is the depth of cut. Depth of cut formula ಏನಲ್ಲ. It is just the material removed in each cut. ನನಗೆ ಹೇಳ್ದಲ್ಲ ಒಂದೊಂದು ಕಟ್ಟಲ್ಲಿ ಎಷ್ಟು ಕೆಳಗಡೆ ಹೋಗಬೇಕು. How much it should go down? How much it should go down to remove the material? How much material in Z axis it has to remove? Z axis ಅಲ್ಲಿ ಎಷ್ಟು material remove ಮಾಡಬೇಕು? ಅದೇ that is the depth of cut. ಈ depth of cut ಜಾಸ್ತಿ ಕೊಡಬಾರ್ದು. You should not give more, because if it is more, the cutter and the spindle is getting more load ಜಾಸ್ತಿ ಹೋಗುತ್ತೆ. And if it is unbearable, if I am giving 1 mm and all, okay, it is cutting and going. If I am giving some 5 mm, it has to take 5 mm cut. ಆ ಟೈಮಲ್ಲಿ ಏನಾಗುತ್ತೆ? If the feed is also more, it will break. The cutter will break. Okay? Now, so these are the main calculations. ಬೇರೆ ಇದೆ MRR, material removal rate, ಅದೆಲ್ಲ ಇದೆ. ಅಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಇಲ್ಲ. That I will just carefully tell one day. Now, what are the general prerequisites? We are going to start a machine. We have programmed everything. We are going to start the machine. What has to be done before, on, and after that? That's what we are going to discuss now. The general prerequisites. So, what should we do? First, before starting the machine has to be cleaned properly. Because if it is not cleaned, the guideways, chip stuck agandre, it won't move properly. Or the setting, the piece when we clamp in the bed, there is something. So it will be slight uneven, which we will not see with our eyes. It is not so we will not see. But what will happen? That will make the difference. Straightness, flatness ಎಲ್ಲ ಹೋಗುತ್ತೆ. So table ಎಲ್ಲ machine ಎಲ್ಲ ಪಕ್ಕಾ clean ಆಗಿರಬೇಕು. Then next, machine clean ಆಗಿದೆ. Next thing we have to look is oil level in the lubrication tank. Now ಗಾಡಿ ಲೋ ಟೈಮ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಏನು ಮಾಡ್ತಾರೆ? ಲಾಂಗ್ ಡ್ರೈವ್ ಹೋಗಕ್ಕೆ ಮುಂಚೆ we will go open the bonnet, check the engine oil, check the brake oil, check the radiator level. We'll check everything. Similarly, in this machine, we have to check various levels of oils and liquids. What are the oils and liquids? First is the lubrication oil. Lubrication oil. Why? What does this lubrication oil do? For the movement. So, lubrication oil has to be checked. Then we have to check the coolant oil. What is coolant? Told you. It is the liquid that cools the material, job and the tool, plus which helps to remove the chips. Okay. Then we have to check the spindle oil. Okay. All these three oils has to be checked. Then I will check the coolant level. Then coolant level, in the coolant level, normally ಈ coolant ಅಂದ್ರೆ they'll be what will be this coolant? Coolant ಅಂದ್ರೆ ಏನದು actually basically? ಅಲ್ಲಲ್ಲ ಏನದು? What is the only water or oil ಏನದು? Oil mixed in the water. So normal water use ಮಾಡಬಹುದಾ? We can, in emergency cases, we can use normal water, but always it is recommended to use the DM water. DM water ಅಂದ್ರೆ demineralized water. We have to use the demineralized water. So there will be a calculation. ಇಷ್ಟು percentage oil ಇರಬೇಕು. I think I already discussed that, right? So that should be that percentage we have to check. Okay. Now when it is less, we can add more water, and once it is too low, we have to add more oil, coolant oil. Then machine lamp glass. There will be lights on the machine side. That will just clean because that's not we have to see properly. Then after switching on for the first time, all the gauges, fans, pumps, everything, we have to see that all are working properly. All the things are sidely fan irutte. Is it running? All these things has to be checked. Okay? Understood? Now, next. Warm up cycle. Warm cycle. Sometimes, if the machine is, I told you already, we'll run for 1000 RPM first, 2000, 3000, 4000. For 5 minutes, we'll be running at slow speeds. One speed increase ಮಾಡಿ, we will reach the higher speed. Why? Because we can directly, now if ಚಿಕ್ಕ ಕಟ್ಟರ್ ಯೂಸ್ ಮಾಡಂದ್ರೆ direct 12,000 RPM ಯೂಸ್ ಮಾಡಬಹುದಾ? No. We won't do that. We will be doing it slowly. Only once. Every time ಅದು ಬೇಡ. Once. Then clamping of workpiece. Check to vice any chakka vice elli clamp ಮಾಡಬಹುದು ಕೂಡ. We should make sure that the work is properly clamped. It is properly clamped. It is tight. If it is loose, what happens? The cutter will fly, the piece will fly, or your dimension will be out. Yesterday in the video you saw, it is not clamped properly, it is just going down or it is flying off. All those things. So we have to make sure that the piece is clamped properly. Then when starting the machine, all the doors, machine doors, frontally door irutte, sideally door irutte, alla idella close ಆಗಿರಬೇಕು. ಯಾಕೆ? Two things. One, the chips will come out into our face. Safety problem. Second thing, the coolant and everything will leak out. It will go out. So all the doors should be closed. Then ಎರಡು ಸ್ವಿಚ್ ಇದೆ. ಒಂದು ಡ್ರೈ ರನ್ ಸ್ವಿಚ್, ಸೊ ಒಂದು ಸ್ವಿಚ್ ಇದೆ. And we have the auto mode in the rotating knob, which we will discuss now. ಈ auto mode time ಅಲ್ಲಿ dry run should be off. Why dry run should be off? Because dry run is something which we do before we start the work. Why? Because we have to see the correct ಆಗಿ ಹೋಗ್ದೆಯಾ. ಒರೇ piece repeat ಮಾಡಂದ್ರೆ okay, but we are doing for the first time that piece. We have to know na cutter correct ಆಗಿ ಹೋಗ್ತಾ ಇದೆ ಇಲ್ಲ ಏನಾದ್ರು ಮಿಸ್ಟೇಕ್ ಇದೆಯಾ. For that we will be using the dry run. But in the normal operation, ಈ dry run on ಆಗಿದ್ರೆ it will not take care of the feed. It will just go in full speed. Again there is danger. Then next, what you should not do. What you should not do. First thing, this first thing, normally people do it, but it is not safe. That is, do not open the machine doors when the work is going on. Not primarily, you should not open the doors. Only in case of emergency, you have to open them. And if you have any doubt, in work time, any doubt, you will make the feed into 0. Manually, we can make in a knob, which I will show you later, the feed will be 0. Feed will be made 0. And then you can turn off the coolant and open and check. Otherwise, it is never recommended to open the door when it is working. Why? It's for our safety. It's for our safety. Then, do not load the tool on the turret or tool holder when the machine is running. For example, in the lathe, one tool will be working here. So the people will think, okay, that tool is working, we'll fit the next tool. We should not do that. Always tool change or anything should be done only after the machine is stopped. Then, do not touch the chuck or spindle when it is running or rotating. Common thing. When it is running, you should not touch it. Sometimes we used to do it. When the power goes suddenly. Sometimes when the power goes suddenly, normally when we press the reset or emergency switch, what happens? The spindle will stop immediately. Spindle will stop immediately. But when the power goes, this braking effect will not happen. Till it will slowly slow down. Very slow. It will from 12,000 to, it will it is reducing like 11,999, 995, 96. Like that it will be reducing. The other thing is from 12,000 it is directly going to 0. In 2 seconds or something it will stop. But this will take around 5 minutes. So some people what they will do, when it is around 4,000 or 3,000 RPM, they will put their hand and to hold it and make it slow. Apply friction. That is not good. That is dangerous. It is not safe. Then, do not adjust the nozzle position when running. But that is, in the initial stage, when the feed is 0, we can adjust the coolant nozzle. But when it is running, don't adjust it because there are chances that injuries may happen. Now, how do we do not remove covers unnecessary, okay? How do we start a CNC machine? How to start a CNC machine? Starting a CNC machine is, first thing, as usual, just like how we on the TV. How you will on the TV? Main plug on. Then we will put the stabilizer on. Nowadays the TVs don't have stabilizer. Earlier days we had stabilizers. Here, first we will put the main panel on. Then we will turn on the stabilizer. Then we have a machine switch. In the machine there will be a switch. That machine will be on and we will wait. Okay? We will wait till the screen is there, na? Or it will show loading. Just like how the computer gets opened. Windows loading it will show, na? Similarly, here also it will show Mitsubishi loading or Fanuc loading. Something it will show. It will keep on loading. Once the main screen comes, we know that machine is ready to operate. So first what we will do? We will release release the emergency switch. Because every time when you off the machine, we will be pressing the emergency button for safety. When cleaning also, we will press the emergency button. Why? By mistake, arrow hogi touch on madbart. So we will be putting the emergency on every time we off. So when on we will be releasing the emergency knob. Then there will be, at that time there will be some errors or something shown. There will be a reset button. We will press that and clear all the errors. This is the normal procedure of starting a CNC machine. So just simple things. Then CNC milling machine. I told you what are things. We have the spindle here. We have spindle here. We have the ATC. What is ATC? Automatic tool changer. We have the automatic tool changer in the side. Then we have the machine base or the bed, which we call, and we have the main control unit. Main control unit. This is the basic important things of the CNC. Main thing in the CNC. Now, MCU. What is MCU? MCU is the communication system between human and the machine. Human and the machine. So here we can see all the details. Where is the X position? Where is the Y position? What is the coolant status? What is the status of the program? What is the program tree? How much percentage it is completed? How much time it has completed? What is the line number? All those things will be seen in the display of the control panel. And here we have the all the switches. You saw in the bottom CNC, right? The switches. We have the all the switches. Now we will go into one by one switches here. Okay, this is what I told. We will be looking at studying about the switches here first. It will be a little confusing for you, but once we go down, I will show you each and everything. What are these switches used for? Understood? Are you okay with that? Okay. Now, first thing, power switches. As you all know, what is power switches used for? Power on, power off. Power on, power off. Then, emergency stop. Emergency stop. Why we have the emergency stop? As the name says, it is to stop in a time of emergency. ಏನೋ ಒಂದು ಎಮರ್ಜೆನ್ಸಿ ಆಯಿತು, ಮೆಷಿನ್ ರನ್ ಆಗ್ತಾ ಇದೆ, ಕಟ್ಟ ಬ್ರೋಕ್, ಆರ್ ಬೈ ಮಿಸ್ಟೇಕ್ ಯಾರಾದ್ರೂ ಕೈಯಲ್ಲಿ ಟಚ್ ಆಗಿದೆ, ಸಮ್ ಇಂಜುರಿ, ಆರ್ ದ ಜಾಬ್ ಇಸ್ ಲೂಸ್. Such things happen. What we will do? We will immediately press the emergency button. So emergency button press ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? The emergency button, two cases I told. One is this emergency case. Second thing, when we are powering off the machine. Last switch off ಮಾಡೋ ಟೈಮಲ್ಲಿ ಕೂಡ emergency use. So this okay. So emergency stop ಮಾಡೋ ಟೈಮಲ್ಲಿ all the work which is being done, the spindle will stop, the movements will stop, everything will be stopped. And again to resume the work means ಅಲ್ಲಿಂದ ವಾಪಸ್ ಸ್ಟಾರ್ಟ್ ಆಗೋದಲ್ಲ. Once you press the emergency stop, ಆ ವರ್ಕ್ ಅಲ್ಲಿ ಸ್ಟಾಪ್ ಆಯ್ತು. ಮತ್ತೆ we'll have to either start from the first or restart from the point by giving other options. So once emergency stop, everything is stopped. What we will do? We will, wherever the cutter is, it will be stopping there. We will move the spindle, move the piece and check and clear the issue. Why I am telling always your hand should be near emergency stop? We should always listen. Any small sound difference. Sometimes when the cutter gets broken, only the corner will get break. The corner will cut. So what will happen? The cutting sound that will change. then we can understand that there is some issue. On the top of the machine, we have three lights, which will be red, yellow, and green. What is there if green is there? Machine is running. Okay. Red. What will be red? Alarm. There is something wrong. And why yellow? Program is complete. Everything is full, and the machine has stopped because the work is complete. These are the three lights in the CNC machine. Most of the machines has this. Then next, we have the cycle start and cycle stop. Cycle start, cycle stop means we are telling the machine start the program or stop the program. Start the program. What is a cycle? Cycle means from one point to another point. We are starting to the next start. So we are telling cycle start will be, this will be operated only in auto or MDI mode, that will show you. So cycle start is for starting or ending a program. Okay. Mostly this feed hold we don't use much, but cycle start is the one we always use to start a program. Then we have the coolant on and coolant off switches. This coolant on, coolant off, as the name says, it will turn on the coolant and turn off the coolant. But for this coolant on to work, we should have previously set the M08 in the machine. We should have given the setting to the M08 into the machine. Then we can use this coolant on and coolant off. Where you will use it? The program is running. We need to check in between. We will pause the machine. There you can off the coolant. Because without offing, if the coolant continuously goes, can we check the finish and everything? No. So we'll be checking we'll be turning off that and turning on temporarily. That's the purpose of the coolant on and coolant off. Then we have the spindle clockwise, spindle counterclockwise, and spindle stop. Even by mistake, we should not press the spindle stop when the work is going on. Because some machines, because here, the machines which we see here in this company, that is the Philips PMB machine. The company where you may go will have BFW or some other machines. All these things, basically it will be the same, but the positioning will be little different. Like how in a car, when you go, Maruti and all will have the indicator on the right side. Maruti will have indicator on the right side of the steering. Whereas this Fiat or some Skoda and all will have on the left side. So slight function is the same. Function is the same. If you move the indicator turns on, indicator turns on. But what will happen? We will get confused. Right? When you suddenly move from a Maruti to this type of a Skoda or something cars, what will happen? You will be taking a turn and you will be putting the wiper instead of indicator. Happens, right? Because we are used to one machine, sudden change will be difficult. So some machines, what happens? The coolant off switch. Something will have only one switch for coolant. Same switch for on or off. Some machines will have two switches. Just by this will be the spindle on or off switch. So your work is going on. You want to turn off the coolant and check the work. Instead of that. So what happens? Sometimes when the work is going on itself, we will not stop the machine. we'll just turn off the code and then see how the work is going on. So in such cases, by mistake, if you press the spindle off, what will happen? The tool will cut, because without turning, the machine is moving, right? So spindle clockwise, spindle counterclockwise, and stop. These are the switches. This clockwise and counterclockwise, actually there is no much need. Why? Because we are giving it in the code. Our G code, we are giving the clockwise or counterclockwise. Which is counterclockwise? Spindle on counterclockwise, what's the code?
0.
Counterclockwise is 04. And clockwise is? Spindle stop is? N05. Good. Then, we have the spindle speed override. Spindle speed override. Sometimes it will be a knob to turn, or sometimes it will be just a switch to the plus or minus. Sometimes it will be a round knob where you can adjust, or sometimes it will be spindle 100%, minus 10%, plus 10%. What we are doing there? We have given the spindle speed as 8000, for example. But we feel, okay, we can go a little more. So we can add it by whatever speed we want. So there will be, and we have to reduce it also. If it is the switches, we will have only 10% decrement. And here in the knob, we can use it 10%, 20%, 30%, whatever speed we need. Then in the feed, we have the feed override. What is feed override? See, sometimes this movement, we have to slow it down or stop. We have to stop it to check. I told you, first time when the cutter comes, we will always keep this feed in 2%. For example, why? It came full speed here. It will come at 150 mm per minute here, if it is F150. But we still need a very slow move, so that we can know what our setting is correct, or it is going to the correct point. So when we start the work, we will always put it in very slow feed. Once the cut starts, we will increase the feed. We have the options to increase from 0 to 200%. Sometimes what will happen? The feed which we are supposed to give is 400 mm per minute. 400. But unfortunately, we gave 200. It is too slow. So when working, we understand, okay, it can go more faster. So what we will do? If you have to change it to 400, we have to change it entirely in the program. Again, we have to go back to the programmer, tell, okay, your feed is wrong, change it. Instead, what we can do? We can just turn this knob and increase the feed. Understood? That is the purpose of this feed rate override. Understood? Any doubts? Any doubts? Feed override. Next, rapid override. Rapid override. Same like feed override, but earlier now rapid, now slow mode. I told you, when you give rapid, it is coming in full speed. So this G00 speed we are controlling using the rapid override. That may not be much. 0, 25, 50, 100. Only 4 options will be there. If you want the rapid also to be slow, we'll keep it in the slow mode. Okay. Then this is the main switch. Mode selection. Anything we do, we have to use with this thing. So we have, in this most used is MDI. MDI is manual data input. We have the auto. The single auto will be either switch or in the controls, because based on machine it will differ. Then we have the job. We have zero return or reference. Sometimes it will be written as 0 return, sometimes it will be written as REF, reference. Then we will have a switch called MPG for manually moving the. So we'll have those who have seen the machine, even in the side of the machine there is a remote like thing to move the axis. To access that, we will use the MPG. So we'll go into each and every point. First is the edit mode. In the edit mode, what we will do? We will edit mode is where this is similar to the MDI, manual data input. We will enter the program manually, or we have a program, we will edit it. That will be done in the edit mode. Okay. Then single auto or the single block. So this normally will not be in the rotation in this knob. It is not must that it should be in the knob. There will be sometimes a switch also, just a button, which we written SBK. SBK. What is happening? I told you the CNC program will be having too many lines, right? Once the SBK is on, we have put the SBK. One line will happen. It will go in one line will happen. Then it will stop. Again we'll press the cycle start. We'll press cycle start. It will run the next line. Stop. Again we'll press the cycle start. It will press the next line. So for going line by line. Why we do this? Why we do this? To check it. To check whether the movement is correct or not. So we'll be using it block by block. That's why it's called single block. And once you have to run the program fully, we will be turning off this one. Once we turn off, it will continuously keep on doing till there is a program end. Then next, auto. What is that? Now we did the single block. We did the single block. But in auto, once we press the cycle start, the program will start from first to end. Okay? Till we press the reset or emergency button. It will go automatically. That is the purpose of this auto. Next is the MDI. MDI means manual data input. Manual data input. What we will do here? Suppose we have set all the things. We want to check whether our center setting is proper. I told you normally our pieces, we'll be setting the 0 in the center. So we'll check whether it has come to the correct position. So what we have to do in the auto, we cannot edit it. Once we put in the MDI, we will manually enter G00, X0, Y0. G00, X0, Y0. We will not give the Z axis first. If we require, we can give the Z axis X0, Y0, Z50. So what will happen? The cutter will come, go to this position, the center position, and then come to 50 mm height. So we can know, is it in the center, approximate value we will get, and we can check. Then MDI, where else we will use? We have to turn on the spindle. We'll turn on the spindle. We'll just put it in the MDI, go to the screen and put M, turning on the spindle, M03, S8000. I told you first the warming up thing is there now. For that we'll use those codes. That is the main purpose of manual data. Basically, we are manually putting the data. Then, or we have to change the tool. We have to check the tool. That time also we will be using the MDA. Next is the handle step or the, I told you, MPG. It will be known as MPG or step. Normally MPG will be there. Here what happens? We can use that remote like thing. That remote like thing is called manual pulse generator. So what we will do? We will move it to the MPG. We have another knob with X, Y, Z. We have the knob. We will turn it to whichever axis we want, and then we will move with the remote. Even in the remote also, we will have the axis, speed, and a big dial to move it. That is the purpose of this handle or step or MPG. Okay, in BFW machines it will be MPG. The next, jog. Jog is nothing but to move. To move only. So what we will have? We will put in the jog. We have the options which is called X, Y, Z. X plus, X minus, Y plus, Y minus, Z plus, Z minus. So what we will do? We will put it in the jog and we will press this. We will press X plus, it will go in the X plus direction. Y will go direction, and Z direction. That is manually to move. So first the same thing what here we are doing now. In the remote which you are doing, if you want to do it in the control panel, there we use the jog. Understood? Any doubt? Any doubt? Doubt there? No. Okay, good. Thank you. Then we have the zero return or it will be written either zero return or it will be written reference. It will be written reference. So what we will do? We will press the zero return. We will turn it to zero return. We will move the knob to X, Y or Z. And when we press plus or minus, it will go to the home positions. We have the home positions, right? So first, which should we move? Z. First, we have to move the Z. Why? Because first the tool should go up. Otherwise, what will happen? Sometimes another clamp work another, it will go and hit there. So first we will move the Z and make it up. Then we will move X and Y. Understood? For example, we have to bring the bed closer to us. We will move the Y axis. First we will lift the Z on top. Then we will move the X and Y. That is the use for the use of the zero return or reference. Okay. So, I told you how we on. We have to press the power on. Then wait for 2-3 minutes to boot the system. Some machines will load fast. Some machines will be slow. Then after booting, clear all the RMs and we'll start the machine. See, this is the machine referencing procedure. This is it. I told you, zero return. We'll press the reference, then we will press button, it will go to the Z dot top, then we'll put the X on top front, X on center and Y on center. This is what happens in the referencing. Okay? Understood? Understood? You want a 5 minutes break? Huh? We'll have tea and have a 5 minutes break. Then we'll continue. Okay?